squared term. So in order to do that, we have to do what's called expanding the binomial. So we want to utilize our Pascal's triangle. The way it works is you start at 1, and then each row is the sum, represents the sums of the row before it or above it. And then you typically add left to right. Anytime you see a space, you consider that 0. So 0 plus 1 produces a 1, and then 1 plus 0 produces another 1. And then we continue. 0 plus 1 is 1, but this time we have two numbers. So 1 plus 1 gives you 2. 1 plus 0 gives you 1. I'll do it again. 0 plus 1 gives you 1. 1 plus 2 gives you 3. 2 plus 1 gives you 3. 1 plus 0 gives you 1. And you continue until you see the number that reflects the exponent you are expanding your binomial to. And so we have to continue our pattern. And now that I have a 5, I know this is the row where I'm going to be able to stop. Now each row relates to an exponent. Use this row here, this diagonal. So this refers to when you have x to the first, x to the second, x to the third, x to the fourth, x to the fifth. Now what I encourage students to do is use a chart to help you keep all of your terms organized. I don't write the best lines, but you know, I always try, because that's all I can ask of you. So, you know. Alright, so in this first row, you're going to put your coefficients. So we call all of the numbers inside your Pascal's triangle, we call them coefficients. And they are going to be coefficients of each term that's going to be produced if we were to carry out this exponent. So remember, polynomials work just like numbers. So with numbers, you can add, subtract, multiply, and carry them to exponents. Well, you can do the same thing to your binomials. And so in this case, we're taking the binomial and carrying it to the 5th power. So instead of doing the actual work, which is x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2 again, because you are expanding it 5 times, right? The amount of work that it's going to take to do that is going to cause for some confusion and a lot of windows for or opportunities for you to kind of mess up and get confused, because it's a lot of the same thing over and over again. So Pascal's triangle allows you to do this work without messing up as much. So we're going to use each number in this row, and I'm simply going to just write down each number the exact same way I see it and in the exact order that it's written in. In my second row, I'm going to look at the first term of the binomial I'm expanding. And I'm going to give each one of these a first term. So, well, each one of these will get the first term. So each one of these will get an x. And now it's time for the exponent. So we're going to start with this exponent, and we're going to count down and give each one of these terms an exponent, starting with 5, and then just simply counting down all the way to 0. Now typically we don't write x to the 0 because anything to the 0 power is just 1. Then I'm going to use the second term. And now I got a lot of arrows just pointing all over the place. So now I'm going to use my second term. In my second term, I'm going to give each one of them a second term. And again, this is the same distributive property you've done before. It's just organized differently. And this time I'm going to go up with the exponent. I'm going to start with 0 and go up to 5. And of course, anything to the 0 power is 1. Now, after I do this, I've actually created a way to get each term that will be produced if we were to do the distributive property for all 5 of these binomials. So again, it's kind of a way for us to skip some steps. Inside of my boxes here, I'm going to simplify each of the terms. So 2 to the 0 is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power is 32. And remember, I'm a math teacher, and so I've done this example 1,000 times by now, and that's why I can come up with the numbers so fast. But the more that you do it, you'll be able to come up with the numbers as well. And I know it seems very overwhelming, but don't let it be. Don't let it be. You'll get good at it. Don't worry. Okay, now at this time, we're going to take each of the parts. They're now factors. And so we're going to multiply them together to get each term. And I'm just writing them outside of I'm just recording what's inside of the boxes. That's what you multiply together. Now, this problem asks us for something very specific. They didn't ask us to complete the problem. They only wanted the coefficient for the x squared term. So this is the x fifth term. This is the x to the fourth term. This is the x to the third term. This is the x squared term. Okay, this is the x to the first term, and this is the x to the 0 term, or the very last term. So since they only wanted the answer for this term, this is the only answer that we're going to do. So it's 10 times 8, which gives you 80, times x squared. And so the answer to the question, what's the coefficient for the x squared term? Well, that answer is going to be 80. 80 is our answer. All right. I'm answering the questions of people whose questions you might not hear. So we have our chart. Again, not the most perfect box, but it'll work. I want to zone in on the exponent that I'm expanding my binomial to, in this case 3. So when I make my Pascal's triangle, or when I refer to it, I want to use the row with the number 3. So I have 1, then 1, 1, 1, 2, 1, 1, 3, 3, 1. So this is my row because it has a 3 in it. So I'm going to take this row, and I'm going to write out my coefficients. 1, 3, 3, 1. And just leave a little space in between. Okay, for my second row, I'm going to use the first term, and I can go ahead and write these things on the side. So this is my coefficient row. This is my first term row. And this is my second term row. So for my first term, we have the variable x. So I have x, and I'm going to start with my exponent and go down. X to the third, x squared, x to the first, and anything to the 0 power is just 1. Are there questions before I move on?
Okay, so basically you just get your first number from your x, like you just counting down. And then for your second you go to 3, then you go to 2, then 1.
Yes.
Okay.
And then this is 0, but anything to the 0 power is 1. So 3, 2, 1, 0. Okay, next we go to the second term. But this time we start at 0 and we go up. Anything to the 0 power is 1. Then 3 to the first, which is 3. 3 squared, which is 9. And 3 to the third, which is 27. And remember, we're doing 3 to the third, not 3 times 3. Okay, questions about this step?
No, I got it so far.
Okay, at this time, we're going to separate them so that we don't get confused. And we're going to multiply all of our factors together in the boxes. And they are going to create our answer. So we have,
Straight down, right?
yes. So I have 1. Did I use the right one? I probably didn't. Alright, I have my 1 times x to the third times 1, 3 times x squared times 3. And again, I had 3 twice this time. It won't always be that way, depending on the number, depending on the second term. 3 times x to the first is just simply x, times 9. And then 1 times 1 times 27. Okay, now I can multiply. One time you multiply the numbers together, and then you typically write your variables down with their exponents. If there's more than one variable, you write them in alphabetical order. So 1 times 1 gives me 1, and then x to the third. So typically we don't write the ones, and we just leave the x to the third by itself. 3 times 3 is 9. And then there's the x squared that we write right next to it. 3 times 9 is 27. There's an x, so we just write the x right next to it. 1 times 1 times 27. These are 3 numbers. You pop them in the calculator. It'll tell you that the answer is 27. It just so happens with the way that 3 works, when you are using when you're expanding, you end up with the 27 twice, but that doesn't happen often. So don't think that you're wrong if you see this again. It just so happens that we're multiplying 9 times 3, just like we would if we were doing 27. Now, because this is a positive, a plus goes in the middle. Because this is a positive, a plus goes in the middle. And this is positive, so a plus goes in the middle. And now we have our answer. So x plus 3 to the third power expands to x cubed plus 9x squared plus 27x plus 27. And now I'll highlight it so we know exactly what the answer is for the problem that we were doing. Okay. How did you do? You don't have to necessarily memorize this in order to be successful. Remember, you have something fantastic in your toolkit if you your intellectual toolkit, and that is your distributive property. If you forget how to do any of this and this is still confusing to you, Just simply use your distributive property over and over again. It's going to produce the same answer. It's just going to take you a little longer. And you have to be a lot more careful, especially when you have a negative or when you have a variable as your second term. But it's not impossible. So this is a tool. Theorems are tools